This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. As we continue to move toward landing the Artemis mission on the Moon, one of the requirements that comes up is for new spacesuit designs. Currently, the astronauts aboard the International Space Station use spacesuits that were designed 45 years ago for the Space Shuttle program. These spacesuits have been refurbished and partially redesigned over the past decades to continue working for low Earth orbit missions. On June 1, 2022, NASA announced the companies who have been selected to develop the next generation of spacesuits that will be used for both the International Space Station as well as for the Artemis missions to the Moon. Here's a SpaceX summary of some of the functions required of a spacesuit.
A spacesuit is a garment worn by astronauts to keep them alive in the harsh environment of outer space, which includes vacuum and temperature extremes. Spacesuits are frequently worn within spacecraft as a safety measure in the event of cabin pressure loss, and they're required for extravehicular activity, or EVA, which is work performed outside of the spaceship. Modern spacesuits add a complicated set of technology and environmental systems to the basic pressure garment to keep the user comfortable and reduce the effort necessary to bend the limbs, while fighting the natural inclination of a soft pressure garment to stiffen against the vacuum. To provide total independence from the spaceship, a self-contained oxygen supply and environmental control system is typically used. IVA, intravehicular activity, EVA, extravehicular activity, and IEVA, intra-extravehicular activity, are three different types of spacesuits. IVA suits are lighter and more comfortable since they're designed to be worn within a pressurized spaceship. They offer enhanced protection from space's severe conditions, such as micrometeoroids and dramatic temperature changes. Outside ships, EVA suits like the EMU are used for planetary exploration or spacewalks. They must protect the wearer from all types of space conditions while also allowing movement and functioning.
Vanessa Weich, the director of the Johnson Space Center, describes a little bit about the importance of the new suits and also gives the announcement of the names of the contractors who will be developing them.
At NASA's Johnson Space Center, we have been working to have new exploration suit capabilities for a number of years. And we will have these suits and they'll be made available for us to support the International Space Station as well as for our Artemis missions going forward. This is a historic day for us, and the history will be made with these suits when we get to the Moon. We will have our first person of color and our first woman that will be wearers and users of these suits in space. So this is a very important day. So without further ado, I am very happy to announce that the awardees will be Axiom Space and Collins Aerospace Industry Team. So congratulations, they're represented today, Axiom Space by Michael Seferdini and the Collins Aerospace Industry Team by Dan Burbank. So as they're developing the service, NASA will be certifying alongside to make sure that they are ready for our astronauts to be a part of them. And then once the suits are then ready, they will be used. These capabilities are for, as I said, for the International Space Station, and we anticipate that we will continue operations on the International Space Station until 2030. So it's important that we have a capability there. And for Artemis, the first use will be on Artemis 3, which will be the first lunar landing for over 50 years.
Dan Burbank with Collins Aerospace Industry Team talks a bit about the importance of the human element in developing the suits.
We want the spacesuit, although we'll often call the spacesuit the world's smallest spacecraft. It's human-shaped, human-sized. It shouldn't feel like a spacecraft. We want to be able to create an immersive environment that for the crew member gives them the most amount of mobility, that complements the crew member's capability rather than constrains it. So we're very excited to do this. We, our heritage corporations worked on the Apollo suit and designed and developed and fielded and operated that Apollo suit. So we've got some surface experience. We've also got more than 4 decades with a spacesuit designed for the space shuttle that was then evolved in its current iteration to be supported for 6 years on board space station with only crew members working on it. And in the process of doing that, we've learned an awful lot. So the goal is to take the foundations that NASA laid with the XCMU in partnership with industry and evolve that technology and create a suit that is compatible with the entire spectrum of crew members. So that commander of Artemis 3, she may weigh 120 pounds on Earth. And so that she has got a suit that's appropriately sized and tailored for her, that doesn't feel like a spacecraft, but feels like a ruggedized set of extreme sport outerwear. That should be the goal.
Laura Kearney, manager of the EPH, or the EVA Human Service Mobility Program, Michael Saffredini of Axiom, and Dan Burbank of Collins Aerospace explain a bit about the commonalities and differences of the various spacesuit types based on their function.
The requirements set for a low Earth orbit suit on space station and a suit on the lunar surface is not significantly different, particularly for the life support system. The differences really come in the pressure garment, the difference in being in zero gravity on space station versus having to walk on the moon where you need all of the mobility. So really at its core, the requirement set is generally the same, but did not dictate to them that it be one suit, two suits, or whatever. We basically bounded for them the say up mass or stowage volume constraints that they would have either in a lander or on space station, and said you only have this much room or this much mass to fit extra parts. You know, how then would you do that? And that's the way we were able to get the innovation from the companies, because they can tell us what they believe their best solution set would be to meet those two differing environments.
So one thing that's very different between the suits, first off, mass is a much bigger constraint and a driver for a surface suit than it is in microgravity. So in microgravity, as a crew member doing a spacewalk, you could be in a 350-pound suit and it's not an impediment. In fact, maybe by some estimations, it could actually enhance, be a more stable platform to be in. But on a planetary environment, especially when you consider that environment is not an engineered spacecraft designed for a spacesuit designed for that spacecraft. Instead, you've got trip hazards in a surface that is not amenable to ease of motion anyway. So we would want to have a lower torso assembly that would have enough mobility for the crew member to walk naturally like they would on planet Earth. On a space station, it's actually not an especially helpful thing. Your legs, you don't really use at all. You use your arms to do the EVA activities. So you almost, on occasion, would you rather just put your feet into a foot restraint and have your lower torso be essentially like a pedestal, rigid, giving you good stability to work. Very, very different design, but it's really, that constraint's really driven by the lower torso assembly. So I think, like Laura said, the technologies, part and parcel with the life support systems, are very, very similar.
And that's the goal, is to make sure the suits are as similar as they can be. The other one that hasn't been mentioned is dust. Dust is a big deal on the moon, and it's one of the things you don't have to worry about in microgravity environment, but it's a big problem on the surface, so that's another thing that we have to deal with.
Michael Saffredini of Axiom and Dan Burbank go on to explain their vision of the evolution of spacesuits to fit new and changing missions in space.
You know, you don't want to build a suit that never evolves. You want to build a suit that can evolve over time. So we'll build a suit, everybody will be happy with it, we'll start using it, we'll want to refine it as we learn more, we'll want to refine it to keep the cost down, we want to refine it to do the job better over the life of the suit. And I fully expect to see that over time as it will evolve of a design and evolve it even more once you get to the lunar surface as well.
Yeah, I would echo that. So I don't think there's anything improper or problematic about evolving the design. So I would say also, with respect to having a suit that would work for one environment or the other, there's a tremendous amount of opportunity to have synergy, to be able to have a suit that supports the microgravity requirements. And then the things you learn there also help to inform how the suit would work on a planetary surface, like the surface of the moon. The suit's got to be interoperable with all the systems it interfaces with, so all the airlocks on International Space Station, on commercial space stations, on lunar landers. on pressurized rovers. The suit's got to be able to interface with all those systems as efficiently and as well as possible. And the most important thing of all is the interoperability with the human element. So we think that is really critical, and we continually learn, and we're going to learn more as we get more and more crew members in the suit and learn how to make it better for them.
Brand new spacesuits. Yep, another step closer to the moon. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.